Okay, it's a couple of minutes after the top of the hour, so I think we can go ahead and get started. First, I want to thank everyone for joining me today. I really appreciate the time that you're taking out of your day to attend this webinar, and I hope that you get some benefit out of it. My name is To Ec2. I am a solutions architect with Amazon Web Services. Oops, excuse me. Sorry, 1 second.
No worries, Todd. Thank you very much, and thank you everybody for attending. Todd, you have also Tim on the call that can support you for anything you may need during the webinar. So I see that the recording started, so I think we're all good to go whenever you're ready. Thank you.
Yep. Okay, as I was saying, thank you everyone for joining me. My name is To Ec2. I'm a solutions architect with Amazon Web Services. I am with the Central SA organization, and we are involved in the public sector of Amazon Web Services. So I'm mainly working with higher education or government organizations or nonprofits. I've been with Amazon Web Services since August of last year. I was actually part of the To Ec2 program, which is another program for helping people transitioning into the cloud. It's more for recent college graduates, and so that's where I began. But I want to tell you a little bit more about my background in that this is a second career for me. I'm a little bit older. I've got kids in high school, and my first career was an artisan bread baker. I started in New Orleans probably in the late 90s, learning how to bake bread. And throughout my career of moving into management, I began using different programs, different ERP systems, and the company I was with started to grow at a pretty massive scale. And we were bought and acquired from a couple different larger companies. And through that process of 10 years, I was moved on to the IT team as a trainer and as a resource for software implementations. And so I started to get more and more involved with the technology side of things, but also maintaining a relationship with the production floors. It was a food manufacturing company that I worked for. And so over the years, I got to learn a little bit more about technology, but also kept my foot in the, excuse me, okay. But I kept my foot in the door when it came to being able to talk to the people on the production floors. And so as I ended my career with that previous company, I had finished my bachelor's degree and I found AWS, the To Ec2 program, and I've been in it since, like I said, last October. And so we went through a similar process of you of learning about kind of the basic functionality of the cloud and the different services available. And now I'm actually customer facing and meeting with customers, trying to help them find solutions for their cloud journeys. Today, we're going to walk through a little bit about Amazon Web Services and a little bit about our global reach, and then move into the Elastic Cloud Compute. So here's our agenda for our discussion today. We'll start with an introduction to AWS and its global reach, and then go into our EC2 Elastic Compute Cloud Service from an overview standpoint, and then we'll dig into some of the finer details.
Sorry, Todd, I'm not sure if you think you're sharing, but I don't see your slides right now. Tim, can you confirm that too? Maybe when I add the team, there you go. Now we do.
Oh, is it
Thank you so
sharing
much.
now?
Yes, perfect.
Excellent.
Thank you.
Okay, I'm glad everyone can see. So this is our agenda for today. So I think the first place that we should start, and I realize that this might be a little repetitive for you, but I always like to start out kind of level setting on our understandings of what the cloud is, what Amazon provides, and maybe there's a few tidbits of information that would be helpful in you with your better understanding of the cloud and what AWS provides. So cloud computing is defined as the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. So in a traditional model, companies, organizations might be buying, owning, and maintaining their own physical data centers and servers. But now you can access those technologies such as compute, as we'll talk about today, storage, and database on an as-needed basis from a cloud provider. And so Amazon Web Services is a cloud provider leader in the industry, and we provide highly reliable, scalable, low-cost infrastructure to the cloud all over the world. And some of the main benefits of that include its low cost, elasticity and agility, so the ability to provision services really on demand and then shut them down when they're no longer needed. So it allows for developers and organizations to really try out different kinds of workloads to find the right solution for them. It's open and flexible, meaning that you only are paying for what you want, and you have the flexibility to shut things down and maybe change a different instance or change a different service or go from, say, a managed service to an unmanaged service. It's also secure because of our global infrastructure and because of the work that it takes to achieve the different compliances that we have. You can be assured that the work that we're doing to secure our cloud, we're providing those benefits onto our customers. And in many cases, it's honestly, it's more secure than most organizations can do on their own, just because of the simple complexity and upkeep required to maintain that security. And then global reach, we've got regions all over the world, and we'll get into that in a second, but it really provides the ability for a customer, say Slack or Lyft, to go in all native on the cloud right from the start and be able to grow and reach all of the world if it's necessary. Customers have selected AWS for years because we've proven ourselves committed to customer success. We believe that we stand apart in the market because of these 7 factors. When it comes to security, you've got fine-grained control, service breadth and depth. We have over 175 services, but in addition to the number of services, the depth of some of those services is quite astounding. And we're also have an incredible pace of innovation, as we'll discuss today. Compute is one of our foundational services, and so there's a lot of time that's been spent over the last decade or so to really innovate on behalf of our customers to provide the service that allows them to operate their workloads in the cloud. Since we've been around since 2006, we've built up a tremendous amount of knowledge base, and so collectively as an organization, we're able to share those resources amongst the different solutions architects, so that what works for one customer, that same type of solution architecture could be applied in other places. Our global footprint, currently we operating 80 availability zones within 25 regions across the globe. And we'll get into more details to what an availability zone is and how we define a region. Machine learning is a very, very fast-growing and eager service for people to be using, and we have quite a few different services such as SageMaker. We've also got SageMaker Studio, which is the first cloud-based integrated development environment. And we're not alone in this. We have a broad ecosystem. We have tens and thousands of AWS partners. Those include both technological partners and consulting partners. And then we've also got a marketplace, which is a digital catalog of softwares ranging, and as you can see, 50 categories and over 8,000 software listings. And then finally, we're an enterprise leader. We've been positioned as a leader in the Gartner Magic Quadrant for cloud infrastructure for a number of years now, and it's something that we're very proud of. Operations is an area where our experience really shines through. Before we even launched our first service in 2006, Amazon.com, the online retailer, was focusing on architecture and operating globally distributed data centers. Our engineers continue to relentlessly pursue the ability to eliminate potential causes of failure, and allows our customers to take advantage of multiple availability zones to provide exceptional operation stability. Additionally, we're committed to 100% transparency for the operational health of our entire global infrastructure. If you were to go online now to the AWS Service Health Dashboard, you would be able to see 24/7 visibility into the real-time operational status of all of our services around the globe. Cloud computing is an inherently high volume, low margin business, and our DNA makes us extremely comfortable in this environment. As I discussed earlier, traditional on-premises data centers require significant upfront capital expenditures, but with our pay-as-you-go model, organizations can adopt a more variable expense model. Our massive economies of scale and lowers our cost considerably, and so we're always taking the opportunity to pass those savings on to our customers. We've actually had 85 price reductions since 2006. We offer flexible pricing models. So if you're interested in on-demand services that can handle spiky workloads, we have that available. We also have reserved instances which can handle or which are best suited for always-on workloads. And then finally, we save customers more as they grow. We have tiered pricing, volume discounts, so that the more you use, the less you pay. Today, 90% of our product roadmap is based on what customers have given us as feedback. The other 10% are things that we have developed on behalf of our customers based on what we think the market could utilize. A great example is our AWS Lambda service. That would be a representation of a 10%. And that is event-driven computing, where you're not provisioning the servers and having to manage all that. You're simply programming triggers that small bits of code can respond to, and it's one of our fastest growing services. Now we'll walk through the AWS Global Reach. Right now, AWS operates 25 regions across the globe, and our concept of a region is a physical location around the world where we cluster data centers. Regions are broken up, or regions include multiple availability zones, typically 3 or more, and an availability zone, or an AZ, is 1 or more discrete data center with redundant power and networking. They're fully isolated partitions of the global infrastructure with their own power, and they're also separated by a meaningful distance. So that might mean many kilometers, up to 100 or 60 miles from each other. And that is to ensure that any potential, different accident that may happen to a different power grid, or any kind of weather event, we can potentially stave off that the different availability zones are far enough away each other so that we can continue to offer our customers the networking and services. This is another diagram of what a region comprises of. We have our 2 transit centers in each region, and those connect the different regions together. But within the region, we use a mesh topology, and that's where each data center and transit center is redundantly connected to each other over our network, so that if one connection goes down, the communication is maintained. AWS runs its own dark network to connect its availability zones, as I mentioned. This privately owned backbone only carries Amazon traffic. The cables connect each AZ and also between different AZs. The standard cable contains 3,456 strands around a steel core which provides strength and allows for tracing of cable using magnetometers. The most recent cables, however, doubled that number of strands and number at 6,912. For each strand, we run 100 gigs. To further increase our data capacity, we employ dense wave division multiplexing, where white color is separated into different colors, almost like a rainbow. The light is split into different frequency channels, and each channel is independent of one another. This allows us to support up to 160 channels for each strand, and this increases the data rate from 100 gigabits to 10 terabytes. This is the Amazon Global Network, and this is also 100% controlled by Amazon. So if you're transferring data from one region to another, it's flowing on that same network. It's completely managed by us, and every one of those links are 100 gigs. And in many cases, a 100 gig network is simply not enough. So in many cases, it's many, many parallel links. And that allows us to operate without the impact of a link cut and provides redundant private capacity between all the different regions. Okay, now that we've talked about the AWS Cloud and its global reach, we'll move into the EC2 specific service. Compute is at the core of nearly every AWS customer infrastructure, whether it be in the form of instances, containers, or serverless compute. As I mentioned, AWS Lambda is a serverless event-driven compute service. We are delivering choice in how you consume compute by supporting existing applications, but also allowing customers to build new applications in ways that suits their business and application needs. And within each of these areas, we are constantly adding new capabilities. EC2 are the most mature area in our compute platform with a deep investment and a long run and proven experience. It's also where customers have the greatest need for choice to support their current and future workloads. For instance, we offer choice across a number of different dimensions. You have a choice between operating systems such as Linux or Windows, as well as choices for architectures, including support for x86 and ARM workloads. For workloads, we have instances which are general purpose as well as optimized for specific needs, such as compute optimized for HPC workloads or memory optimized for big data analytics. Over the last year, we have introduced new capabilities to enhance our instances, including bare metal and attached SSD, and most recently, enhanced networking. These instances are packaged for you in many different ways, and you can choose one of our AMIs, or you can customize your own images, or select from additional varieties of AMIs provided in our community. And those instances are available through flexibility and purchasing models to meet your business and budgetary needs. In some instances, it might even include licensing, which can be complex, especially for Windows workloads. An Amazon Machine Image provides the information required to launch an instance, such as the operating system and any other applications. Instances can be in a running state or a stop state, and that can affect how IP addresses are assigned if they're public. It can also affect on, depending on what storage type you're using, it can affect that as well. But every instance must be deployed into a virtual private cloud or VPC. The Amazon VPC is a service that lets you launch AWS resources into a logically isolated virtual network that you define. You have complete control over your virtual network environment, including the selection of your own IP address ranges, creation of subnets, and configuration of routing tables and network gateways. The Amazon Elastic Block Store is a high-performant block storage service designed to work with EC2. So if EC2 is the server, EBS is the hard drive that's connected to that server that's mounted that does all your persistent storage. Designed for mission-critical systems, EBS volumes are actually replicated within an availability zone and can easily scale to petabytes. So even though virtually it only looks like one volume, it's actually replicated on the back end within the availability zone to provide redundancy and fault tolerance. You can also use EBS snapshots with automated lifecycle policies to back up your volumes to to Amazon S3 or the simple storage service, and that is housed in the same region. So you can take a snapshot of your volume and then store that in a bucket, and then you can create new volumes based on that snapshot that would be point-in-time replicas. As I stated, Amazon Machine Images provide the information required to launch an instance. You specify an AMI when you launch an instance. You can launch multiple instances from a single AMI when you need multiple instances with the same configuration, which can be really handy when you're working with auto-scaling groups. You can also use different AMIs to launch instances when you need instances with different configurations. So the AMI will include the template for the root volume, might be the operating system, the applications that are installed. It also includes the launch permissions. So this was where you identify which AWS accounts can use AMIs. You can create private AMIs, or you can make them public and share them with other accounts, or make them available throughout the marketplace. And then finally, a block device that maps to specific volumes to attach to the instance. So any instance can have multiple EBS volumes attached to it. So, and that is often the case where you might have one volume that is just for the root device, and then other volumes that are used to segregate applications. You can copy an AMI within the same region or to different regions. When you no longer require an AMI, you can deregister it. AWS provides community AMIs, which you can use as is or modify, and you can also save it as your own. The marketplace, as I mentioned earlier, is a digital catalog with thousands of software listings. So if you want a specific hardened server or a Windows server with certain attributes to it, or you know of a vendor that specializes in a specific type of workload, you can find their AMIs available. can see here the EC2 operating systems are supported. Many different flavors of Windows Server over the years, including also Linux flavors. Linux, the Amazon Linux 2 and the Amazon Linux AMI are supported and maintained Linux images provided by AWS. And here are some of the features of why those are so popular. It's a stable, secure, high-performant execution environment for running applications on EC2. It's provided at no cost, so you could pick up a base level Linux 2 Amazon AMI and load any kind of software and then save it as a copy and keep that privately, so that when you're wanting to deploy new instances or when you want to boot up an instance, it doesn't take as long because you're not having to load software at the time of boot. Repository access to multiple versions of MySQL, PostgreSQL, Python, Ruby, Tomcat, and more common packages are also available in the Linux AMIs, the Amazon Linux AMIs, and they're also updated on a regular basis to include the latest components. And these updates are also made available in Yum repositories for installation of running instances. Beyond the operating system, we are providing you the choice of processor and architecture to build the applications you need with the flexibility and choice that you want. We believe that providing greater choice, customers can choose the right compute to power their application and workload. We have a rich and long-term partnership with Intel, and their Cascade Lake processor is the key to powering some of our most powerful instances, including the C5 Metal and the C5 24XL instance types. NVIDIA helps us to power your machine learning and graphics workloads. And then we also announced support for AMD and the AMD EPYC processor, and we are the only cloud with AMD available today. Lastly, we announced that AWS has released a new processor, the Graviton, based on the ARM architecture. Here's a graphic that can help show you all the different instance types that are available to our customers, and just show you the depth and the breadth of opportunities and choices that customers have. Starting at the left, we have our general purpose instances, which provide a balance of compute and memory and networking resources and can be used for a variety of diverse workloads. These instances are ideal for applications that use resources in equal proportions, such as web servers or code repositories. Our compute optimized instances are ideal for compute-bound applications that benefit from high-performance processors. Instances belonging to this family are well suited for batch processing workloads, media transcoding, high-performance web servers, high-performance computing, scientific modeling, or dedicating gaming servers. Memory optimized instances are designed for fast performance for workloads that process large data sets in memory. Accelerated compute instances use hardware accelerators or coprocessors to perform functions such as floating point number calculations, graphics processing, or data pattern matching more efficiently than possible than running software running on CPUs. Storage optimized instances are designed for workloads that require high sequential read and write access to very large data sets on local storage. They're optimized to deliver tens of thousands of low latency random I/O operations per second to applications. Our instance names can look a little bit strange at first, but it's easy to break them down once you understand how they're formulated. First, we have the instance family. As you saw from the previous slide, C belongs to the compute family. And then we've got the instance generation. So on a fairly regular basis, once instances families are created, they're iterating through new generations that provide higher power, sometimes at a lower cost, and we keep improving upon what we already know. Next is the attribute. So in this instance, type is going to be a graviton instance. And then finally, the instance size, which relates to a combination of attributes, including how much memory is available and the number of vCPUs, which allows you to choose the right instance type for your workload. A vCPU is a virtual central processing unit. One or more vCPUs are assigned to every virtual machine within the cloud environment. Each vCPU is seen as a single physical CPU core by the virtual machine's operating system. A thread is created by a compute process. Every time you open an application, it creates a thread which will handle all of the tasks of that specific application. Likewise, the more applications you open, the more threads will be created. Threads are the virtual components which divide the physical core of a CPU into virtual multiple cores. A single CPU core can have up to 2 threads per core. Here we want to just briefly talk about how the instance type sizes might change. And so 2 of those factors or attributes that I'd mentioned are memory and storage. And memory refers to the component within your computer that allows for short-term data access, also called dynamic random access memory. Your computer performs many operations by accessing data stored in the short-term memory, including operations such as editing a document, loading applications, and browsing the internet. The speed and performance of your system depends on the amount of memory that is installed on your computer. Separately, storage is the component of your computer that allows you to store and access data on a long-term basis. Usually the storage comes in the form of a solid-state drive or a hard drive. Storage houses your applications, your operating system, and files for an indefinite period of time. So in this instance, the storage would be the EBS volumes that we discussed earlier, whereas the memory would be attached to the instance size. Here's a brief explanation or a brief explanation using this graphic to explain how the instance sizes change and how they're really just kind of doubling of each other. So an extra large instance, a 2x large would be 2 of the regular extra larges, and then 4x large would be 2 of the 2x larges. And this also relates to the vCPUs in memory. For instance, the C4 extra large has 4 vCPUs and 7.5 gigabits of memory, whereas the 2XL is double, meaning it has 8 vCPUs and 15 gigabits of memory. Just as with operating systems and processors, we are helping to reduce the costs with new graphics workloads and for machine learning. With elastic graphics and new elastic inference, we are enabling customers to cost effectively add acceleration to their workloads. Elastic graphics and elastic inference are both physical graphics cards in our data centers. However, when you add them to your EC2, you're basically creating a network connection between your EC2 instance and the graphics or inference cards, even if they don't sit on the same physical server. And then you can access those graphics through the use of API calls from your EC2 instance. Elastic graphics enables you to add the right amount of graphics acceleration for a fraction of the cost of using standalone graphics instances. Similarly, with elastic inference, you can reduce deep learning inference costs up to 75%. You can also attach fractional size of the GPU to an EC2 or SageMaker instance and scale up or down as needed. You can use EC2 autoscaling to scale inference acceleration up and down per your needs. So again, this goes back to giving our customers the choice and using the right size workloads, but having the flexibility and agility to use only what they need when they need it. As discussed earlier, there's 4 different ways to purchase compute. We have on-demand instances, which is a pay-as-you-go model with no commitment, and this is best for our fluctuating workloads. Reserved instances are for long-term commitments that are always on workloads. Savings plans are just like reserved instances, but the monetary commitment is based on compute and can be used across our compute services, including Fargate and EC2. And then finally, spot instances is the same pay-as-you-go pricing as on-demand, but up to 90% off. So essentially, you're bidding on spare EC2 capacity in our data centers. The only caveat is that AWS can reclaim those EC2 instances with a 2-minute warning. And so this is best for fault-tolerant workloads that can be stopped and started. All 4 purchasing options use the same underlying EC2 instances and the AWS infrastructure across 25 regions. As your cloud environments and you should scale, we hear from customers that optimizing costs and correctly scaling for capacity is becoming essential. This graphic shows that you can do this today with the tools we offer and that we've made it easier for you to manage cost and complexity so that you can continue to grow your cloud footprint. Many customers today use Spot instances for fault-tolerant and flexible workloads, such as big data, containers, and web services. Spot instances are spare capacity. Every week on average, customers are using more compute capacity on Spot instances than customers were using on the whole of Amazon EC2 in 2013. This will give you an idea of the scale of which you're operating and growing. Customers tell us that they want more flexibility in using Spot in combination with other pricing models, and they need even more flexibility in scaling capacity using multiple instances when needed based on usage or availability of capacity. So this graphic, you can see that as a baseline for those always-on workloads, were you recommending that customer use reserved instances when possible to save money? But then when we hit those spiky workloads, so if you were an online retailer during the holiday season, you may want to use on-demand for spiky, or even if it's fault-tolerant workloads, you could use a combination of both on-demand and Spot instances. One of the newer features that was announced in just the last couple of years is hibernation for EC2 instances. So in the past, if you had a Spot instance that was being reclaimed, the only option would be to shut it down. And so that requires quite a bit of work to restart processes, and it's time lost that you could be using to operate your workloads. So hibernation is really similar to like opening and closing your laptop. It shuts it down, but the state is saved so that if you're able to restart that workload, you can go back to where you were. Lets you pause and resume your work by retaining memory across your start and stop cycles. Applications relying on memory contents can pick up exactly where they left off instead of building that memory footprint all over again. The ability to stop and start instances has helped customers lower costs as they pay only for what they consume without losing the state of the instance. This functionally is exposed via familiar start and stop APIs. It saves you on compute costs as hibernation is you only pay the storage costs and the minimal warm-up times. Hibernation is a significant next step in our efforts to help customers optimize their scaling strategies, and they can respond quickly to demand surges without compromising on costs. We talked a little bit earlier about the pace of innovation. And so this is an interesting graphic to show that over the first 11 years, from 2006 to 2017, that single instance that we had originally launched grew to over 70 different instances. But surprising, or not unsurprisingly, but just in the last few years, we've nearly quadrupled those number of offerings based again on what customers have asked for and what we feel like provides them the best service. This rapid innovation for customers means greater choices of compute, networking, and storage so that you can better tailor resources to the cloud to both optimize performance and costs and quickly scale. ARM processors are extensively used in consumer electronic devices such as smartphones, tablets, multimedia players, and other mobile devices such as wearables. Because of their reduced instruction set, they require fewer transistors, which enable a smaller die size for the integrated circuitry. The ARM processor's small size and reduced complexity lower power consumption, which makes them more suitable for increasingly miniaturized devices. The AWS Graviton is the second generation of ARM chips that are coming from Annapurna, the chip design company in Israel that we acquired a few years ago. And our customers gave us the feedback that supporting ARM was a great step forward and that our first generation processor was a good start. But our customers also pushed us to innovate faster and improve their performance so they could use these instances on more demanding workloads. We relaunched the AWS Graviton 2 processor, which was a huge step forward in that it offered 7 times the performance, 4 times the number of compute cores with more support for machine learning, video, and HPC, and 5 times faster memory than in previous generations. With all of these processors, we're bringing innovation to the broader set of workloads and enabling customers to bring new classes of ARM-based workloads to the cloud. A generation of our Graviton-powered instances from our mainstream M, C, and R class instances. Graviton 2-based instances offer up to 40% better price performance versus x86-based instances, and are available with or without local instance storage and supports a broad spectrum of workloads, everything from application servers to video encoding, an HPC to microservices, open source databases, and in-memory caches. Now we'll move into more specific design principles of how EC2 is utilized in our data centers. So if you're not familiar with virtualization, a hypervisor is a software that creates and runs the virtual machines or the virtual servers. A hypervisor, sometimes called a virtual machine monitor, isolates the hypervisor operating system and resources from the virtual machines and enables the creation and management of those VMs. The physical hardware, when used as a hypervisor, is called the host, while the many VMs that use its resources are called the guests. The hypervisor treats resources like CPU, memory, and storage as a pool that can be easily reallocated between existing guests or new virtual machines. Hypervisors make it possible to use more of a system's available resources and provide greater IT mobility since guest virtual machines are independent of the host hardware. This means they can be easily moved between different servers. There are two main hypervisor types referred to as type 1 or bare metal and type 2, which are also called hosted. The type 1 hypervisor acts like a lightweight operating system and runs directly on the host's hardware, while the type 2 hypervisor runs as a software layer like any other program or operating system. So here we see our original architectures were Xen-based hypervisors, but more recently we've introduced the Nitro hypervisor, which is a custom KVN-based hypervisor, which includes less server resources and more resources for the customer. And I'll get into more details as to what that looks like in a second. So this helps to describe visually what it looks like. And so we've got our physical servers on the bottom, then we've got our host server, which would be our host operating system. Then we've got the hypervisor sitting above that, and that would be the Xen or the Nitro. And then finally, we've got our EC2 instances, which are guests on top of the hypervisor. When an instance is launched, we look across our fleet for an available slot to run the instance. When the instance is launched, we both hard partition the memory and CPU allocations so that we're not ballooning memory or oversubscribing memory or CPU. Every instance must be launched with at least one security group, which controls all the network access in and out of the instance. Security groups control access regardless of whether the instance is talking to another instance that's attached to the same hypervisor or is within the same AZ or another AZ or even across the world. So this is a diagram or a graphic of what say the older Xen hypervisors look like, where everything is included on the server, and it's more of a monolithic approach in that the hypervisor controls the networking, storage, and management altogether. And that's a traditional setup. But with the Nitro system, our idea was that we could break apart all of those functions into separate components to reduce our cost by delivering all the resources of a server to customers versus having to hold back some of it for management software. The Nitro system includes really three concepts. We've got the Nitro cards, which are a family of cards that offloads and accelerates IOs for functions, ultimately increasing overall system performance. So the family of cards might include the Nitro card for VPC, the Nitro card for EBS, or the Nitro card for instance storage. The security chip enables the most secure cloud platform with minimized attack surface, as virtualization and security functions are offloaded to the dedicated hardware and software. Additionally, a lockdown security model prohibits all administrative access, including those of Amazon employees, eliminating the possibility for human error or tampering. And then finally, the Nitro hypervisor is a lightweight hypervisor that manages memory and CPU allocation and delivers performance that is virtually undistinguishable from bare metal. Our C5 and M5 instances are our first Nitro-based instances, and we have many more to come. They provide 25 to 50% price performance improvement over previous generations, depending on your specific workload. They also provide 50% to 80% improvement to bandwidth and 20 to 30% improvement in IOPS over previous generations. Now here is a simple architecture, very simple, of a three-tiered web application, which includes the concepts that we talked about today. We've got our region, and then within our region, we've got multiple availability zones, and we've got our VPC, which is our virtual private cloud. The VPC is only able to exist in a specific region. It can't extend beyond one region, but it can span multiple availability zones. So here you can see we've got our VPC with both our public and private subnets. So public subnets have access to have ingress access, so it can be accessible from the internet. And then we've got our private subnets, which cannot be accessed. And the reason I'm bringing this up with EC2 is I wanted to walk through a little bit of how the different subnets that you create in your VPC, along with security groups and your network access control lists, can really allow you to provide a secure environment. First, we've got our EC2 security groups. And so these are virtual firewalls that you can set rules for each instance. So security groups are applied to the instance. And this is focused on how they can control network traffic. In each rule you provide, you give it a name, and you allow, or you configure the different protocols that are allowed, as well as any and all port ranges. So if you left it open to the world, would be for maybe a web server, but you could also define it to, I could create a security group today that would only use the IP address on my laptop that I'm using to talk to you today. And then finally, you can set up multiple IP address ranges. So you can control the traffic coming into each specific instance. In the diagram or the architecture that I showed earlier, we had different layers of the three-tier application. And so each of those in this instance would show different security groups. So you can see in the center of the screen, we've got 4 different security groups, one called web, one app, one database, and one management. And it allows different protocols on different ports from different sources. But the great thing about the tiered EC2 groups is that it's a hierarchical setup, whereas for your web security group, which is your web server, you allow HTTP traffic over port 80 from 0.0.0.0/0. That's really from anywhere in the world. So that was going to have to be a hardened server to make sure that it's secure. But then when we go to the application server, you can see that there's only 2 entries or 2 rules. One is over port 8080, and that it only allows traffic from the web server. So the only way to get traffic to the app server is from the instance in front of it, as well as for administrative purposes, we've opened up port 22 for TCP traffic to allow SSH into each of the instances. And so by using this hierarchical structure, we can also ensure that database server traffic is only coming from the application server and no place else. Even though these different servers may exist in the same VPC or even in the same availability zone, you can see that traffic is directed through each security group. So if security groups are on the instance level, NACLs or network access control lists are on the subnet level. So each subnet, each VPC is broken up into different subnets. We had created public and private, and so you can create NACL rules for an optional layer of security for your VPCs that's actually works as an additional firewall controlling traffic in and out. So another distinction between security groups and NACLs is that NACLs are stateful, and so you have to control traffic. You have to allow traffic both in and out, whereas with security groups it's stateless. And so it immediately allows, once traffic is allowed in, it is automatically allowed out. The other distinction with the NACL is that you can set deny rules. So you can see here that rules are given a rule number, and so they're evaluated in order, with the wildcard being sort of like infinity. So it's going to go through and it's going to start to execute the rules in order as long as it finds one that it matches. And as soon as it matches, then it executes that rule and it doesn't go any further. So the default NACLs on the inbound and outbound rules, we have a rule for 100 on both, which will be executed first, which is the default, allowing from the source of 0.0/0. So it allows all traffic in and out. Again, this is an optional additional layer of security, and it's applied at the subnet level as opposed to the instance level. You can add and remove rules from your default ACL and create additional network ACLs for your VPC. The changes are applied automatically or immediately with both security groups and with NACLs. Okay, and that's really all I have today. I just wanted to give you a brief overview of the service and some new and exciting things that we're doing with AWS with our Nitro and Graviton 2 instances, and then give you a brief overview of how EC2s are deployed into a VPC within the region, within the subnet, and then how you can apply some base level security. Obviously, for a production environment, you might add other services such as web firewalls or DDoS protection, but this just gives you a brief overview of how you can do simple network workloads for compute and how you can start to secure some of those. So we've got a few minutes left, so I'm going to take everyone off mute. If you have any questions, I do my best to help you, do my best to answer them. If not, I can get you some more information. Let me just find out how to unmute everybody. Okay, I believe that I've tried to unmute everyone, so if you have any questions, please speak up, or you can drop it in the chat window as well, and I will try to answer. Sorry, this is the first time I'm using GoToWebinar as a presenter, so just give me a second to get used to it. I see a question from Tim. Is the new hypervisor like a microkernel as opposed to a monolithic kernel? And Tim, yes, I believe that was the idea. If you think about the idea of using microservices, talk about it with containerization and modernizing applications, we try to break up the monolithic into smaller pieces, and I think that's what they're trying to achieve with the new hypervisor. The Nitros, they're breaking that up so that each component of the Nitro system can be updated independently, but also it doesn't require the same amount of resources available because it's broken up. Next question is, does the hypervisor have any kind of user land or user space? I'm not actually sure about that. I remember from the presentation, what I'd mentioned was that they had separated and that users weren't allowed to access some of, even Amazon employees weren't allowed to access some of that, some of the aspects of the Nitro system. So I'm not really sure if it has a user space or user land. Does anyone have any other questions? I'm trying to unmute people. I think it's working, but I feel like you might be muted on your own.
Hi, Todd.
Hi.
Okay, yeah, so yeah, mine is not questions particularly on the scope, but I just wanted to ask for the recorded session, where would we be able to access it?
I'm going to wait for Antonella to come off of mute. Maybe she can provide information as to where the recording would be available. I'm not entirely sure.
Okay. All right, no worries. Thank you.
Yep. I see another question from Tim about what would be a good CPU class for moderate sized DynamoDB bases, DB tables. And I think it really kind of depends. It really comes down to what your IOPS and what your throughput is going to look like. So I'm not really sure how the best answer to that question without really diving deeper into what the workload might be. There's a great opportunity within the console that you can use different instance type sizing to best understand what is the best appropriate for the workload.
Okay, hey, can you hear me?
Yes.
This is Tim. I just wanted to answer that one question about the recording for the webinar. It will be posted in one of the modules in the graduate training class as soon as it becomes available. Generally, they're available in an hour or so, but I will post an announcement as soon as it's available.
Excellent.
All right, thanks.
Excellent. Well, if there's no other questions, I just really want to let you know that I appreciate all of your time today, and I really enjoyed this opportunity to speak with you, and you're welcome to reach out to me. My name is fairly unique, so if you want to reach out on LinkedIn, I'm available, and I'd love to help you in any way that I can. As I stated, I came from a non-traditional background from food manufacturing, so I appreciate what Restart is doing and how challenging it may be if you're not in a technical role already or if you're trying to transition into one. So please reach out if there's anything I can do to help.
Todd, thank you very, very much. For me, I appreciated the presentation very, very much today, and I learned something about the Nitro hypervisor, so thank you very much.
Yeah, I'm happy to be here. I'm looking forward to doing more sessions in the future.
Sounds good to me.
Yeah, thanks a lot, Todd, as well. I also learned about the new AWS Nitro concept. Yeah, so yeah, thanks.
Yeah, absolutely. Okay, well, take everyone. I'm going to go ahead and end the webinar. And again, I appreciate your time today and enjoy the rest of your day. Thank you so much.
Thanks again, Todd. Appreciate it.